One second. Yeah. Please write this down. I just started the recording. Please write this down clearly in your notes, and never should the coefficients be interpreted as 4 grams or 3 grams or 2 grams. They should always be interpreted. Yeah, Nandana?
I said done.
Yeah, good. Angel, are you writing this?
Yes, sir.
Okay. So now we'll just get into the calculation and prove why do we need to actually write the coefficients. It means that you need to balance the equations. What is the need? So we'll go back, guys, here. We'll just write this down here. What is the molecular mass of aluminum, guys? Sorry, atomic mass of aluminum? Any idea? 27, okay. Oxygen is 16, right?
Yeah. Yes, sir.
Okay. Now what we'll do is, right, how many moles of oxygen do you have here? You have 4 into 27. You're talking about atoms here. Let us say 4 into 27, right? Oxygen is 16 into 2 into 3. That's what it is.
Yes, sir.
I want you guys to calculate all this, right? And aluminum is how much? 2 into 27 plus 16 into 3. Give me the answers for this.
4 into 27 is 100.
108
108.
plus,
16 into 2 into 3 is 96.
fantastic, 96. What about this?
So 54. 54.
How much is this?
2 into 27 is 54 and 16 into 3 is 48.
48.
Okay. One minute, guys.
So it equals to 102.
No. Somewhere we are going wrong. Aluminum is this one. 1 second, guys. Aluminum is this. Oxygen is 48. Let's calculate this once again. Okay. Al2 is 54. 54 plus this is how much? 16 into 3 is 48. 48 into 54 is how much, guys? Just give me this here. 1 second.
102.
100.
Yeah. And how many moles of this is there here? That's what we missed here.
Yeah.
See, you had 2 moles of this, right? For all the others, you have multiplied with moles here. So you have 102 into 2, right? So this becomes 204 and this becomes 204. It means to say that we actually balance it and prove that the mass of the reactants here on this side will be same as the mass of the products that are formed. Got this, guys?
Yes.
Yeah, I missed the 2 here, guys. That's it, nothing else. Right, 54 and 48, you get 102. 102 into 2 is 204. 108 plus 96 will give you 204. So 204 on the reactant side and 204 on the. Is this clear, guys?
Yes.
Yes, sir.
Okay. So now you understand that, okay, these coefficients which are there attached to all these elements are got only after balancing the equation. And you need to balance the equation because you know that there is a law that was proposed, law of conservation of mass. You remember this? Who proposed this law? Who proposed this law, guys? You remember this long back you studied, or did you study it in your previous class?
Or some Antonio or something.
Yeah, Lavoisier,
Yeah,
right?
I don't know. Is it correct? Antonio.
Yeah, Antonio Lavoisier.
Okay.
Okay. So we'll look into his name later on, but see, basically what I wanted to tell you guys is if something goes into a chemical factory to an extent of 100% and some products are formed, basically in a chemical reaction, the reactants would again have 80% and 20% of the total mass that actually went into the chemical factory. So in a chemical reaction, basically the mass is completely conserved, and this is law of conservation of mass. And that is the reason why you need to always balance your equations. Why do you need to balance your equations? Because it follows the law of conservation of mass or matter. Who gave this? It was given by Lavoisier. Though it is Lavoisier, you actually pronounce it as Lavoisier in 1788. Is this clear, guys?
Yes, sir.
So
Yes.
you should understand why the equation needs to be balanced. The equation needs to be balanced because, right, it is entirely dependent on the law of conservation of mass. And that we had already seen in the previous example where aluminum reacted with oxygen to give rise to aluminum oxide, where on the reactant side we had 204 and on the product side we again had 204. That's clear, guys?
Yes, sir.
Yes, sir.
Yeah. Now, what you should know is like you should know certain common facts about a chemical equation. First of all, whenever you write a chemical equation, you should write a chemical equation so that all the formulas are correct. And at the end, once again, I'm reiterating the same fact because you should follow the law of conservation of mass and see that it is properly balanced. So again, reactants, the substance that exists before a chemical change are called as reactants, right? Whereas the products are the new substances that are formed during a chemical reaction. Do you know all this, guys? I'm just running through
Yes,
these slides, assuming that you have already read this somewhere in the previous classes.
yes,
Nandana, should I go slow here?
So it's all right. I'm taking it down.
Should I wait for you to note this down? You know what are reactants and products, right?
Yeah.
So these are definitions. The substance that exists before a chemical change are called as reactants, and the substances that are formed after a chemical change are called as products. That's fine?
Yes, I've taken it down.
Yeah. And the chemical equation indicates the reactants and products of a reaction. Now, how to write a chemical equation? I want you guys actually to write this down very clearly. The steps that you follow when you write a chemical equation. See, steps that you follow when we write a chemical equation. Please write this down. The first thing that you'll have to write is write the equation in words. Please note this down. And then write the symbols and the formula of the reactants and the products. Then the third step is you need to check whether the equation is balanced or not. And you know why it should be balanced, because
it completely depends on the
everything,
law of
yeah,
conservation of mass.
yeah. Now, this is very important. The formulas that you write, the fourth point, the second point is one and the same, but I'm again reiterating the same thing, saying that, okay, the formula has to be written correctly. Otherwise, the entire thing will mess up. Then you can add the state symbols. Write these points down and then let me know.
Done, sir.
All of you all are done? Pritika and Nandana?
Yes.
No, sir, 1 minute. I'm in the last
Pritika,
point.
Nandana and Angel.
Yes, sir, I'm done.
Okay. So we look at a particular equation here. See, what we say is methane reacts with oxygen to form carbon dioxide and water. So what do you do first? You just write down the word equation of the reaction that methane gas reacts with oxygen to form carbon dioxide and water. This is what you write. That's what I told you. Step 1 should be this. Then what you do, you know that these are reactants and these are products. Then what do? You start writing the formula on both the sides. Is that okay?
Yes.
Yes, sir.
Okay. Now, then you balance the equation and all. We'll get into balancing later on. Okay. Before getting into the formulas, guys, you'll have to clearly understand what a chemical formula is. So we have taken the molecule that is widely available for widely used by us. I don't say widely available because water is getting like less and less and sparse these days. Like, let's talk about water. When you take one molecule of water, actually, how do you read this when you take one molecule of water? You say that, okay, one molecule of water contains 2 hydrogen atoms and 1 oxygen atom. Is that okay?
Yes, sir.
And similarly, if you say 2 molecules of water, it should contain 4 atoms of hydrogen, 2 atoms of oxygen. I think this is clear, guys.
Yes, sir.
Yes, sir.
Okay. Angel, can you just tell me, like, one molecule of hydrogen peroxide would contain what in terms of atoms or in terms of the composition of H2O2?
So what? Your voice was breaking. Can you repeat?
Yeah.
Can you repeat what you said? I didn't hear.
See, one molecule of hydrogen peroxide, right? In
Yes.
terms of composition, like what we have described earlier, that one molecule of H2O would contain 2 hydrogen atoms and 1 atom of oxygen.
Yes.
Like, how would you write H2O2 in terms of its composition?
So we would say there are 2 hydrogen atoms and 2 oxygen atoms.
Good. Now, see here again, I was just depicting this. This is the step 3 that we'll have to do. Let us say there are 2 hydrogen and 2 chlorine on the reactant side, and you have the table here. This is what we generally do. We'll get into the OneNote and we'll be solving the problems here. Okay. Before getting into OneNote, guys, Nandana, you're there with me? Hello, Nandana?
So can you repeat what you said? I wasn't able to hear you.
No. So when you start with, how many hydrogen atoms are there here in the reactant side?
2.
And in the chlorine side, you have 2.
2.
But how many do you have here in the product side before balancing?
1.
How many hydrogen do you have here?
1.
1. And chlorine?
Also 1.
Also. So now what happens, like the simple thing that you'll have to do is you'll have to see that this should be containing 2 and this should be containing 2. Simple, right?
Yes.
So what do you do now? You have 1 and 1. Now you go to now you try to balance and you put the coefficient of 2 here. Now, once you put the coefficient of 2 there, everything seems to look good here. You'll be having 2 hydrogen here, 2 chlorine here, and 2 hydrogen here and 2 chlorine. Is this clear, guys?
Yes, sir.
Yes.
So that's what is the coefficient means for the entire equation, because you need to balance the number of atoms for a particular element on the reactant side as well as on the product side. Are you guys really getting me?
Yes, sir. Understood.
Yes, sir.
Yeah. Okay, guys, we'll talk about this later on, but okay. What we'll do is we'll just get into OneNote to make things interesting as well as easy for you guys to understand. We'll just get into OneNote now. And let me add a page here. Okay, guys. You can see my screen, all of you?
Yes, sir.
Okay. Now, we'll talk about balancing. Balancing a chemical equation. What we'll do is we'll balance two reactions and then we'll take a break. Right? Is it okay, guys?
Yes, sir.
Yes, sir.
So,
Okay,
it is
sir.
yeah. Pritika?
I said yes.
Yeah. Balancing a chemical equation. See, I'm telling you some rules here, guys, for the hit and trial method. The hit and trial method.
So what are the methods we need to know?
See, hit and trial method, and there is a partial equation method, which we're going to discuss in the next class. But today we are going to talk about hit and trial method and the ABCD method.
Okay.
But see, these are the three methods that we're going to talk about. The hit and trial, the ABCD method. Is that okay?
Yes, sir.
Yes, sir.
The first one is hit and trial, the second one is partial equation, and the third one is the ABCD. What I'll do is we'll finish the hit and trial today and the ABCD method, and we'll take up the partial equation method later on. Is that okay?
Yes, sir.
Yes.
Yeah. So first, what we'll look into is we'll look into the hit and trial method. Okay. The first rule for the hit and trial method. What are the rules for the hit and trial method here? See, the first rule is you balance the metal that is there in the equation. Balance the metal that is there in the equation. Are you writing this down?
Yes,
Yes.
sir.
Yes, sir.
Next, what you do is you balance the non-metal. Balance the non-metal. Third, then you try and balance the oxygen. Try and balance the oxygen. And the fourth one, what you do is you balance hydrogen. Is this clear, guys?
Yes,
So
sir.
first you need to balance the metal, then you need to balance the non-metal, then you need to balance the oxygen, then you need to balance hydrogen. Is this okay?
Yes, sir.
Yes, sir.
All right. We'll take up an example now. Iron reacts with water to give rise to Fe3O4 and hydrogen. Right? We'll take this step by step, guys. Just write this down and let me know when you're finished.
Done, sir.
Done? Okay. Now, in the trial and error method, what you normally do is right? First, you write down the elements on the reactant side. What are the elements? The first one is the metal, that is the iron, right? There is no other non-metal other than oxygen and hydrogen. So what do you write down? What do you write? You write oxygen now and then write the hydrogen. Is there anything else, guys?
No, sir.
So,
Okay.
Sir, so why did you write oxygen before? Does it matter?
No, I didn't. Nandana, yes, once again. Why did
So
I
does
write?
the order matter on how you write it?
No, it doesn't matter. Like the order doesn't matter, but you can write it down because you remember I told you it is metal, non-metal, oxygen, and hydrogen. The
Okay,
rules
sir.
I told you, right?
Yeah.
That's the reason why. Or else you can write it down as hydrogen or oxygen also. It doesn't matter, right?
Okay, sir.
So how many number of atoms are there here for iron?
1,
1,
Oxygen,
1,
hydrogen,
2,
2. Now we'll write this down here. Iron, oxygen, and hydrogen. How many do you have here? 3,
3,
3, 4,
4 and 2.
2. Iron.
Yes.
Here it's clear. Okay.
yes, sir.
They are not balanced because you have 3 atoms of iron here. Sorry, 1 atom of hydrogen iron here on the reactant side and 3 atoms of iron here on this. What did I tell you? The first thing that needs to be balanced is the metal. That's what I told you.
yes, sir.
You can hear me, guys, right?
Yeah,
Yes.
Yes,
Yeah.
sir, we can hear you.
Yeah. The first thing that needs to be balanced is the metal here, right? And if you balance the metal here, right, how many? It needs to be 3 here, right?
Yeah.
So you have to have 3 here. Is that okay? So if you put 3 there, I am audible, guys?
Yes.
Yes, sir.
Just because the power went off and came again, there may be a lag in the internet. That's why I'm asking you. Right. Okay. So let us say the first thing that you have done, what? You have put a 3 here. When you put 3 again, let's see. This now has 3 iron. Oxygen remains the same because you have done nothing with oxygen. And hydrogen remains the same as 2. This is clear?
Yes, sir.
Yes.
Right? Okay. What is the next thing that I told you that all of us should do? We should balance.
the non-metal.
Balance, see, non-metal. You don't have any other non-metal other than oxygen and hydrogen. Hi, Anna.
Yeah,
Yes.
Yes, sir.
So we'll balance oxygen now. Is that okay?
yes, sir.
So you have 4 here, right? But you have only 1 here, right? So you write a 4 here so that you'll have 4 oxygen here. Is that okay? Nandana?
Yes, sir.
Yes.
Yeah, sir. But sir, if you write it before the hydrogen,
No, we'll do it. We'll balance for the hydrogen at the end.
okay, sir.
See, what am I telling you? Follow it up slowly. This is the way you do in the hit and trial method. I'll tell you the easiest method later on, the ABCD method, which is a wonderful method wherein there's no need to follow this at all. But since it is there in your syllabus, you'll have to learn this. Okay. What do you do in the hit and trial method? The first thing is you write down the atoms of each and every element that is there on the right hand side, that is the reactant side, and then write the elements on the left hand side and the number of atoms of each of the elements on the right product side. Fine. First we have balanced iron. Now we have balanced, after doing this, what do you have? You still have 3 iron atoms, right? You have how many? Oxygen is how many now? 4.
Now it's
And hydrogen is how many now?
Hydrogen is also 6.
Hydrogen.
6.
6. Hydrogen will be, yes, 6.
6.
No, sorry, 4, sir.
There's a 4.
Oh, sir, I think it's 6, sir.
4 into 2 is 8, right?
Oh,
Oh,
into
okay,
I
okay.
thought adding it.
No, don't add it, right? The coefficients are right for the multiples of, right? 4 into 2 is how much?
8.
Yeah.
Okay. So now what do you have here? You have 3 and 4, 3 and 4, but only hydrogen is not balanced. Is that okay?
Yes, sir.
Now what do? You simply add, see that hydrogen to be balanced, to have 8 here, you should add a coefficient of 4 here, so that finally on the product side, you'll be having 3 iron, 4 oxygen, and 8 hydrogen. Is this clear, guys? Nandana?
Yes, sir.
So you can add to both sides.
What you can add to both sides, Pratika?
I didn't say anything.
Yes, sir, never mind. I got it.
Nandana, this is clear?
Yes, sir.
See, what have we done first? I'm just repeating this entire thing once again. We have written each and every element on the right hand side and on the left hand side, that is the reactants and the products respectively. And the number of atoms I've written for each of the elements initially, even before starting the balancing. Then we first balance the metal. Is that okay, guys?
Yes, sir.
And I
Yes,
want every one of you to write all these steps clearly. This is how you'll have to define your hit and trial method. The first thing that you would balance is a metal. And once the metal is balanced, let us say you have written 3 here, then write down the number of atoms of all the elements again, 3, 1, and 2. And then see the next thing to be balanced. If you have a non-metal, you should look for a non-metal other than oxygen and hydrogen. Now you don't have any other non-metal here. So you look at oxygen here now, and then you look at hydrogen. So first you balance oxygen. Since you have 4 atoms of oxygen on the product side here, so you multiply with 4 here so that you'll have 4 atoms of oxygen. You'll be having 3. Is that clear, guys?
Yes, sir.
Yes, sir.
3, 4. And then by adding 4 here, you have 8 atoms of hydrogen. So to balance hydrogen, you need to add a coefficient of 4. So finally, you'll have 8 atoms of hydrogen. Is this clear, guys?
Yes, sir.
Yes, sir.
Shall we take up one problem before we break for tea or coffee or whatever you have? Shall we take one more problem?
Yes,
Yeah.
sir.
Yeah. Good, guys. Okay. But this is going to be a bit tough. But what I'll ask you to do is like, just try this down and we'll go for one more problem afterwards. Okay. FeS2 reacts with oxygen to give rise to Fe2O3, Fe2O3 plus SO2. Can you start doing this, guys? All of you all are there with me?
Yes, sir.
Yes, sir.
Yes, sir.
Shall I start solving it, guys? We'll solve together to save time.
Yeah, okay.
Yes, sir.
Right, guys. Yeah.
Sir, I'm a bit confused because there are 2 oxygens.
Yeah. That's why I told you that this is a bit tough, but good that you should try such problems so that it'll be easy for you to. Okay, Nandana, right?
Yes, sir.
Please let me know like how many atoms of iron, sulfur, air, and oxygen are there on the right hand side.
1 atom of iron
1 atom of iron, yeah.
and sulfur.
2, right?
Yeah, and then 2 oxygen.
2 oxygen. Let's put down the same here. Iron, sulfur, and oxygen. Iron, you have 2. Sulfur, how many?
1.
1. And how many do you have?
So is it 5? Because
5. Fantastic. You got it right. Great. Now, what should we do first? Nandana? We should balance out of all these 3 atoms. Which is the atom that we need to balance first?
the metal, which is iron.
Very good. Fantastic. So you have it here as, what do you have it here?
2.
So you write it as 2. Is that okay?
Yeah.
Now we'll check it out. You have 2. You have 4. Is that okay?
Yeah.
You have 2 oxygen. This is clear till here?
Yes, sir.
Pritika,
Yes, sir.
this is clear till here.
Yes, sir.
Right. What should we do next? We should balance what?
The sulfur.
Sulfur.
Oh, wait. Oh, yeah, sulfur.
Sulfur. It's a next non-metal, right?
Yeah.
So what should we do? We should balance sulfur. Is that okay?
Yeah.
Now, to balance sulfur, how many do you have here? You have 4 here. So what do you do?
Add a 4 before.
Add a 4 before this. Now we'll look at this. How many iron atoms do you have here?
2.
2. Fantastic. How many sulfur do you have?
4.
4. Now how many oxygen do you have?
8.
Come on.
8.
Pritika, you're leaving this 3.
Oh, yeah. So after doing that, should I add the 3 or multiply it?
Oh,
4 into 2 will be 8.
8. And you
then
have
8.
to add the other ones, right?
Okay. 8,
Right?
11.
11. Nandana, this is clear?
Yes, sir. So for the oxygen, in the first one, why is it still 2? Shouldn't it also be 4?
Do we have a coefficient attached to this?
Oh, okay.
We added the coefficient
only
only to
applies for
this compound, right?
Yeah, okay.
We don't have the coefficient is still 1 here, right?
Yeah.
Clear, Nandana?
Yes, I got it.
So here, the same thing here. The coefficient here, if nothing is written, it is 1. And if you add a coefficient here, it is for that particular compound in the product side. It is for that compound in the reactant side. Should be very clear, right?
Yeah.
Yeah. Now we'll move ahead. Angel, now it's your turn.
Yes, sir.
Now we need to balance what? We have balanced iron.
So we have to balance.
We have balanced sulfur.
Yes, sir. So now oxygen.
We need to balance oxygen. Is that okay?
Yes.
Okay. Now listen to me, guys, all 3 of you. You should be very careful here for such kind of problems. What do you have here? Nandana, what is the number you have here?
11.
11. You're clear with that number, all of you? Pritika and Angel?
Yes, sir.
Right. So now, to get 11 here, what is that coefficient that you need to multiply here? 5.5? Hi, Anna.
Yeah.
All of you agree with me?
Yes, sir.
We have reached a consensus saying that, okay, we have to multiply with 5.5 to get 11 here because you have 2 here. 5.5 into 2 will make it 11 oxygen atoms. Clear?
Yes, sir.
Okay. Now what do we do is we write the same thing here. Look at me. We are writing 2 FeS2 plus 11 can be written as 5.5 can be written as 11 by 2.
Yes,
Yeah.
sir.
11 by 2 O2, right? And this is what Fe2O3 plus 4 SO2. This is clear till here, guys? The same thing I've written.
Yes, sir.
See, I have taken a 2 from here. I've written the same 2. 5.5, I've written it as 11.2. There's a coefficient of 1. There's nothing to be written because if you have a coefficient of 1, there's no need to write anything. Now you have a coefficient of 4 here. You have written a coefficient of 4. This is clear till here?
Yes.
Yeah. Now, look at this. Can you have atoms in fractions, guys? No, no.
I've never yeah, I don't know.
So
I don't think
to
so.
remove the fraction here, right? If you multiply 11 by 2 by 11, 11 by 2 into 2, you can cancel this. Hi, Anna.
Yes, sir.
So what do we do? The entire equation we multiply it with. Nandana,
Yes, sir.
got it?
Yeah.
So the entire equation, what do we do now? We have got FeS2 11 by 2. So we multiply with 2. So why do we multiply with 2? Because we want to remove this denominator.
Yeah.
So now if you multiply with 2, this becomes 4 FeS2 plus 11 O2, right? This
Yes.
gives rise to 2 Fe2O3 because you are multiplying the coefficient of 1 with 2 now, right?
Yeah. And that'll become 8.
8 SO2. Hi, Anna.
Yes, sir.
So now this is the balanced equation. I want you guys to write this down clearly. Take a break after you write. And once you finish, you let me know and take a break. Is this clear, guys?
Yes, sir. It's clear.
Yes,
So I had a doubt which I had in my question paper. It's also related to balancing.
1 second. Yes, Angel. Yeah.
So I had a doubt which was in my question paper for the exam. I lost a mark in that. So it's also related to balancing. It's the same hidden trial method. So the question is calcium hydroxide plus nitric acid gives calcium nitrate plus water. So I lost marks in that balancing. So I wanted to ask how to do it.
You don't know how to do it?
No, so the rest of it I got.
We'll take up that example after the break.
Yes.
What did you say? Calcium hydroxide?
Plus nitric acid
Very good.
gives rise to calcium nitrate plus water.
Fantastic. We'll do it after the class. Okay. Hey, but all of you, did you finish this? You go to the break only after you have noted down this.
Yes, I've noted it down.
Angel, even you'll have to write this.
Yes, sir, answer.
And let me know when you finish. Then only we'll go for a break. Otherwise, there's no point. Again, we'll have to continue this after the break.
sir, done, sir.
Yeah. So we'll be meeting at 7:50, guys. It's 7:45 and 5 minutes break. Nandana, you're done?
Yes, I've written it down.
Angel?
Yes, sir.
Okay. 7:50 we're meeting, okay? Let me start. Okay. Okay. See, calcium hydroxide,
Yes.
CaOH twice plus, what is that?
So
HNO3.
nitric acid.
Nitric acid is HNO3. Is that okay?
Yes.
This will give rise to what?
So calcium nitrate, CaNO3 twice,
CaNO3 twice
plus
plus
water.
water.
Yes.
See, for such kind of problems, I was about to take up this problem with you guys. Follow me carefully, guys. See, the normal method, what I told you was, what did I tell you? It's a metal, non-metal, and a, what is next, guys?
Hydrogen, oxygen, and hydrogen.
Oxygen and hydrogen.
Hydrogen.
This is what I told you, guys. All of you are there with me?
Yes, sir.
Yes, sir.
Sure.
Yes.
Yes, sir.
Okay. Yeah. Concentrate. See, for such kind of problems where you have polyatomic ions or molecules, you have polyatomic molecules here. Hi, Anna.
Yes, sir.
I think I taught you guys the polyatomic molecules. You were there in the class when I taught you molecular formulas,
Yes.
chemical formulas. So what we generally do is calcium is there here. And what is the polyatomic molecule here? Hydroxyl group. Hi, Anna.
Yes, sir.
And what do you have here in nitric acid? H. And the polyatomic molecule is nitrate. Hi, Anna. Clear? It's clear?
Yes, sir.
Yes, sir.
Good. Now, forget about the charge that is there here. It's not necessary here. We'll just write OH minus. Now, here what do we have? We have calcium here. And what do we have? Nitrate here, NO3. And can you split water into H and OH minus, guys? Can you do this? All of you here.
Yeah, yeah.
Can you split water into H and OH minus or not? This you know?
Yes, sir.
Angel? Angel, you're there. Hello, Angel.
Yes, sir. I just used a Wi-Fi connection, so I got disconnected.
So you have hydrogen and you can split water into H plus and OH minus. So you're going to write this as H and OH. So whatever you're going to balance is now with respect to H and OH minus for water. This is clear till here?
Yes.
What have we done? We have taken all the polyatomic ion molecules and we have written them. We have taken, in, for example, in calcium hydroxide, you have calcium and OH minus, which is nothing but a polyatomic OH minus, and you have HNO3, H and NO3 here. Now, how many calcium atoms are there here on the reactant side? Angel?
Sir, can you repeat it?
How many calcium?
Sir, 1.
1. How many hydroxyl?
Sir, 2.
2. How many hydrogen?
Sir, 1.
And how many nitrate? 1.
Yes.
Is this clear till here?
Yes, sir.
Pritika and Nandana?
Yes,
Yes,
sir.
sir. It's clear.
All good, Nandana?
Yes, sir. I'm understanding.
Okay. Now you have calcium here, 1. Nitrate here, you have 2. Hi, Anna.
Yes, sir.
And hydrogen here, you have 2. You have 2 or 1?
Sir, 2.
No. See, look at this, please. The reason why I've written 2 is just to make you understand that whatever I've written is wrong because you have split this into H and OH, right? When you split this into H and OH, one of the hydrogen gets into hydroxyl polyatomic molecule. Now, when there is polyatomic ion here that is present, so the number of hydrogen left alone is only 1, and you have 1 hydroxyl. This is clear, guys?
Yes, sir.
See, I just want you guys to understand. That's why I had written it as 2 there. earlier, because you should clearly understand that 2 is wrong because one of the hydrogen atoms gets along with the hydroxyl group. Therefore, you have this. Is this okay till here?
Yes.
Any doubts?
No, sir, no doubt.
Okay,
No, sir.
1 and 1. Right. Now we'll start balancing. What is the metal here? Calcium? Is calcium balanced, guys?
Yes, sir. Calcium is balanced.
Calcium is balanced.
Yes, sir.
Is the hydroxyl balanced next?
So hydroxide is no, sir.
Okay. Now what we'll do is, since the hydroxyl is not balanced, what shall we do? You have only one hydroxyl group here. So what we generally do is we add, you want 2 hydroxyl groups. So you add a coefficient of 2 here. Hi, Anna.
Yes.
This is clear till here?
Yes, sir.
Yes,
See,
sir.
whatever we are balancing, once you have split water into H and OH minus ions, you have to now start balancing with this one and not with this one, right? We'll start balancing here. Now, how many calcium do you have? 1. You have nitrate, 2. Step by step we'll go. How many hydrogen you have? 2. And how many hydroxyl do you have now?
So two.
1 or 2?
So two.
2. Nandana is clear till here?
Yes, sir.
Sure.
Yes, sir. I think I'm understanding what you're saying.
Okay, good. Now, look at this. Then we'll go to the next. We'll go to the next polyatomic molecule. Now, what do you have polyatomic molecule as here? NO3 is the next one. How many NO3 do you have on the product side? 2.
Yes.
So here you have 1. So what do? We multiply this with 2. Is that okay?
Yes, sir.
So when we multiply this with 2, now again we write you have 1 calcium, hydroxyl is 2 again, hydrogen is 2 here, nitrate is 2 here. Is that okay, guys?
Yes.
Now you look at hydrogen. Hydrogen is automatically balanced now. Is that okay? 1,
Yes.
2, 2 and 2. You have 1, 2, 2 and 2. Is that okay?
Yes, sir.
Yes, sir.
So the balanced equation now becomes calcium hydroxide plus 2HNO3. Are you understanding, guys, whatever I'm teaching you?
Yes, sir.
Yes, sir.
Calcium nitrate here, CO3, 2 here, and this becomes H2O, 2H2O. Is that okay? Now
Yes.
this is 2H2O yogurt. Is that okay?
Yes, sir.
Okay.
Yes, sir.
We'll do 2 more problems. We'll do 2 more problems, one on this polyatomic molecules and then one on the oxygen that we have balanced in the last example, right? We'll see how far you can solve these 2 and then we'll call it a day, right? This is clear, guys. Pritika, is it clear?
Yes, sir. Yes, sir.
Sure.
Yeah, sure.
Okay. Now, let me give you one equation here. You have butane here, right? We'll talk about butane, right? C4H10 reacting with oxygen to give rise to carbon dioxide and water. Is this okay till here?
Yes.
Balance this equation, give me. Let's see how far you can balance this. Shall we start, guys?
Yes, sir.
Need some more time? Are you done?
So 2 more minutes.
Yeah.
Sir, since
Yes,
this
Nandana.
is my first time learning it, can you can you give me some problems that I can practice? Like
Yeah.
after class?
Yeah. After the class, like what I'll do is I'll give an assignment. Okay.
Okay, sir.
I'll give an assignment. I'll post an assignment on Guru offline activities. I'll include some problems, right? I'll
Okay.
include some good problems and I'll, right? You can balance the equations. Not an issue at all. It comes by practice only. Okay.
Yes, sir.
You understand the basics, right?
Yes, sir.
Yeah. If you understood the basics, like everything will be clear. No issues. None. Shall we proceed, guys?
Yes, sir.
Yeah. Angel, are you done?
Not yet, sir.
Okay, guys. Yeah, we'll do this way. Let's guys.
So can you repeat?
Is my voice clear?
So it was breaking before. It's fine now.
Now it's okay, right?
Yeah.
Yeah. Let me know now.
It's fine, sir.
Yes, we can hear you.
Yeah. We'll go. We'll proceed, guys. Yeah. What are the atoms on the reactant side? Nandana. Carbon, hydrogen, and oxygen.
Yes, sir.
Okay. And you again have carbon, hydrogen, and oxygen. Okay. On the left hand side. Now, how many carbon do you have here on the reactant side?
4.
4. How many hydrogen do you have?
10.
10. Oxygen?
2.
2. Carbon?
1.
1. Hydrogen?
2.
2. Oxygen?
1.
Nandana, oxygen.
Oh, 2. No, 3.
2 plus 1 is 3. Okay.
Yeah, 3.
Right. Good. Got this right here. Okay. Well, you don't have a metal here, so we'll go with a non-metal there. So carbon, when you look at, you have 4 and 1. So what do you normally do? We'll first try to balance carbon, right? We'll multiply with 4. Is that okay?
Yes, sir.
So you have 4 carbon now. But look at hydrogen. Hydrogen are still 2. But how many oxygen do you have now? How many
8.
oxygen do you have now?
8.
Hmm?
8.
Okay. 8. Nandana, you're leaving 1 oxygen here with water.
So you add that, right?
Yeah. So
So
you'll have 9. Okay. See, 4 into 2 is 8 plus 1. That becomes 9.
Yeah.
Yes or no?
Yes, sir.
Pratika. Pratika,
Yes, sir. Yes, sir. I'm here.
you're there?
Yeah.
Yeah. You understood, right? You had
Yes, sir.
carbon first here. So carbon needs to be balanced. When you want to balance carbon, what do? You multiply this with 4. So you're going to have 4 carbon, right? And
Yeah.
you have 2 hydrogen here, but oxygen will be 4 into 2, 8 plus the 1 that is there along with water. This is clear till here?
Yes, sir.
Yeah. Now, what is the next one that we need to balance? Carbon is balanced. What is the next one that we need to balance?
Hydrogen.
Hydrogen. How many hydrogen do you have?
There's 10.
This 10 hydrogen on the other side. So what do?
You
I
multiply
add 5 over here.
Very good. You just put a 5 over here. Nandana, you agree with that?
Yes, sir.
So when you put 5 over here, what will happen?
The hydrogen will become 10 and then the oxygen will be 5. Plus 9.
Okay, we'll go step by step. How many carbon do you have now?
4.
Count the number of carbons here. 4.
4.
Okay. How many oxygen do you have? Nandana, I'm talking to you now. Nandana,
Yes, sir.
how many oxygen do you have now? 4 into 2, 8. 5 here. So the oxygen will be 13 and the hydrogen will be 10. Is that clear?
Yes, sir.
Kritika
Yes.
Yes, sir.
and Angel, do you accept that you have around 13 oxygen here?
Yes, sir.
So everything is balanced now except for oxygen. You have 4 carbon here, 4 carbon here.
Why is it 13? 9 plus 5 will be 14.
How is it 9 now? You have 4 into 2, 8 plus 5, right?
Oh, okay.
9 was earlier because the coefficient was 1 there.
Yeah.
Now you have the coefficient of 5 here. So you add, there you have added 8 plus 1. Now you should add 8 plus 5.
5, okay.
Got it?
Yes, sir.
Hi, Anna.
Yes, sir, got it.
Good. Let's proceed. So, Nandana, you're there with me?
Yes, I'm here.
So, you have 13 here, right?
Yeah.
So, to get 13 here, what is the coefficient that you need to have here to multiply with 2 to get 13?
So you can do 2 into 13 by 2.
Yes, that is 6.5 or 13 by 2. 6.5 or nothing but 13 by 2. Is that okay?
Yes, sir.
Right? Till here? Okay. Now what, we'll write this down. You have C4H10 plus, what do you have? 13 by 2 O2 plus 4, sorry, not plus, it's 4 CO2 plus 5 H2O. Till here it's clear, guys?
Yes.
Yes, sir.
Sir.
Then what do we do now? To remove the denominator here, what do we do?
2. So we multiply the whole thing.
Yeah, we multiply the whole thing with 2. So what will happen? This is 2C4H10. Yes, plus 13O2, which will give rise to 8CO2 plus 10 H2O. Is this clear, guys? Still here?
Yes, sir.
Got this right?
Yes, sir.
Any doubts here?
No, sir.
Any doubts here?
No,
So, so all of you all create. Shall we take up one more example in this angle?
Yes.
One good
Yes,
example.
sir.
Okay. We'll take up one example with respect to the polyatomic ions. And then we'll break for the day. Right. Oh, let me look into. Okay, guys. Ammonium hydroxide. Anyways, I'll give you around 10 problems for you. Right. I'll compile 10 problems for you and I'll post it in the offline activities by tomorrow afternoon. Right. Are
Okay,
you
sir.
all doing the offline activities, guys?
yes, sir.
Angel and Pratika, what about you? Are you taking the tests that we
So
did?
yeah, I've taken the tests.
What about the offline activities?
So the one on Guru, right?
The one on Guru, yes.
I'm doing it.
Offline activities.
Yeah, the one you have to write on the paper and
Yes.
I did it.
One day suddenly we'll ask you to show us, right? And then probably. Okay, guys. See, this I have included only for you to understand the polyatomic nature again. You remember we have done one with NH4O, with the other one, like what she has asked us, like calcium hydroxide, when it reacted with HNO3, we got what? Calcium nitrate, CaNO3 twice, plus H2O. That's what we have got. So on similar grounds, try working out this. NH4OH, H3PO4, NH4 thrice PO4 plus H2O. I'll be giving you 5 minutes, guys, 7 minutes. Let us take 7 minutes. You're getting it, guys? What is the first thing that you'll have to do? Nandana?
So you write all the elements.
Elements or the polyatomic ions here?
The polyatomic ion.
Right. Shall I start doing it, guys?
Yes, sir.
Are you trying it yourselves, Nandana?
Yes, I'm doing it right now.
Yeah. Okay. I'll just write down a few things here before explaining so that you will follow me later on. I'm just writing the polyatomic ions here and the atoms that are there. Okay. Here, again, water, I'm going to split it as H and OH here. So here you're going to have NH4. OH is anyways there, right? H is anyways there, and you have a PO4. So this is the first thing that you'll have to do. How many of you have done this? All of you have done this?
Yes,
Yes, sir.
Yes, sir.
Nandana?
Yes, sir, I did this.
Very good. Excellent. Then it is very easy for us. The only thing that you'll have to do is just look into the polyatomic ions here. Nothing else. It is so easy solving this problem looking into polyatomic ions rather than individual elements. I tell you. That's the reason why
I got
wherever
it.
you find polyatomic ions, you'll have to solve using the polyatomic ions. Yes, Nandana?
Yeah, so I think after doing this, I found my answer.
Your voice, Nandana. Once again.
Yes, I was saying after doing this, I figured out the answer.
Okay. You're done with the answer?
Yes,
got-
sir.
Good. Post me in the chat box. Just the coefficients. If you're done. Can you do that, Nandana?
Yes, I'm sending it.
Yeah. Right, guys. Post me in the chat box if you're finished. Otherwise, follow me here. All of you, Pritika and Angel,
Yes, sir.
right?
so when I'm done, should I send you the answer?
Okay.
Yes, I sent you the answer.
Great. Good, Nandana. Fantastic. I'm waiting for your answer, Angel. Excellent. Angel, good. Kritika, I'm waiting for your answer.
Sir, I'm not sure about this one.
Okay.
Didn't do it.
Okay, you want me to explain?
Yeah, this is one question.
Yeah. Okay. Nandana, you're there with me. Angel and Nandana are there with me, right?
Yes, sir.
Okay. How many NH4, NH4OH, NH4 do we have here?
One.
One.
One. How many hydrogen here?
Um,
Four.
so
Oh no, wait.
Done?
3.
Yes.
Hi, Anna.
Yes,
Yes,
sir.
sir.
Okay, how many do we have here? 3,
So 3.
3.
1 OH, 2 hydrogen, right?
Yes, sir. 2 hydrogen.
1 PO. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Kritika, this is clear.
Yes, sir.
Okay. Now you need to balance the ammonium ion. Is that okay? Kritika,
Yes, sir.
so you have 3 here. What do?
So you had 3 there.
You add 3 there. So now again we'll write all these. All right? If you add 3 there, you have 3 this NH4, 3 OH minus. H3 would remain the same because you added no coefficient to it. PO4 would again remain the same. And here, everything again remains the same. 3, 1, 2, 1 because you didn't change the coefficients. This is clear till here?
Yes, sir.
Okay. Now look at this. What is that you need to balance now?
Sir, OH.
OH. How many OH do you have here?
3 and then there's 1 over there.
So you have how many?
3.
3 here and you have 1 here. So we'll add 3 here. Is that okay?
Yes, sir.
So when you add 3 here, the coefficient should be added to this, not to this molecule. Is that okay? And the coefficient is added here. You have 3 OH. Is that okay?
Yes, sir.
And how many PO4? You have 1 PO4. Have we committed a mistake, guys, somewhere? How many hydrogen do you have? We have 3 hydrogen here. Can anyone make out what mistake have I committed? See, it's actually when you talk about H and OH, right? It is 1 hydrogen here, guys, earlier. It is not 2. Is that okay?
Okay, sir.
Yes.
You understand? We have only 1 here. You have only 1 hydrogen here. Pritika, is that clear?
Yes, sir.
So whatever all of you have done is correct. The H2 I have taken earlier as 2 is wrong because it already split into H and OH minus. So by committing mistakes, we learn. That's the reason why I purposefully put certain things here for you to clearly understand here and find out the mistake later on so that we do not commit the same mistake over and over again. Is that clear, guys?
Yes, sir.
Yeah, sir. But sir, I used 2, but I got the right answer.
No. We'll do it once again. Maybe you're getting confused here, right? Don't look at this at all, right? Forget about this. You have got NH4, OH, and what is this here? 3 is the right answer. Like I tell you where you got confused because I've just purposefully added 2 there because none of you was pointing out the mistake there. I continued till the end and then corrected my mistake, what I've actually committed purposefully. Anyways, right, here it is H and here you have PO4 minus, right? Till here it's clear, Nandana?
Yes, sir.
Okay, now we have NH4, PO4. Oh, so we'll write in the same order, guys. Sorry for repeatedly doing this. Anyways, OH minus and H plus, and we have PO4 here. Till here it's okay, right? Okay, Nandana. What do you get here? NH4 you have got 1, OH you have got 1, PO4 you have got 1, and hydrogen you have got 3. That's what you have got earlier?
Yeah, sir. I did that earlier.
Right, very good, excellent. And then you have multiplied this with 3.
Yeah.
You get 3. What do you get? 3. OH you get 3, right? PO4 you get 3, and this you get as 1. Sorry, H you get 1. This is clear till here?
Yes, sir.
Hi, Anna,
Yes, sir.
Pritika and Angel.
Yes, sir.
Yes, sir.
Okay. Here, what do we have earlier? We have 3. OH is 1. Hydrogen is 1. PO4 is 1. Here is where in the last demonstration I have purposefully committed a mistake by taking 2. See, though you consider H2O here, there are no 2 oxygen because there are no 2 hydrogen because 1 hydrogen has gone along with the hydroxyl group. You remember? I told you this earlier in the other example as well. Nandana.
Yes, sir.
But sir, I used to.
What?
So when I was doing it, I used 2 instead of 1.
You should not get it then. See, maybe there's some small mistake somewhere. You just check it out. See,
Okay.
this is H2O, right? This we have split into H and OH minus, right?
Yeah.
Now, when you do that, NH4, this is 3 you have got, right? PO4, you have got 1. H, you have got 1 here. And OH minus, you have got 1 here. This is clear?
Yes, sir.
Okay. And here, just because you have 3 ammonium ions here, you have multiplied 3 here, and you have got 3 ammonium, right? 3 hydroxyl, right? Because the coefficient is 3 here, 3 hydroxyl. And here you have got 3 hydrogen and 1 PO4. This is clear, right?
Yes, sir.
Yeah. Now, what do we need to balance? We need to balance the hydroxyl here. Anna?
Yeah.
See, the hydroxyl is 3 here, and this hydroxyl and hydrogen you need to balance. Both of them are 3 here, right?
Yeah.
So now we multiply with 3 here. See, whenever you multiply with 3, don't multiply with H2O when you have split that into H and OH. You have to multiply with H and OH only. That's what I told you, Nandana.
Yes, sir.
So now what's happening? Just have a look. You have 3. So how many hydroxyl do you have here after you multiply this with 3? Nandana.
Yes, sir. Can you repeat?
How many hydroxyl do you have when you multiply? Let us say this is H and OH, right? And you have multiplied this with 3. How many hydroxyl do you have? 3 hydroxyl?
Yeah.
So you have 3 hydroxyl. And how many hydrogen do you have?
3.
3. And how many PO4 are there? 1. So it is balanced. 3, 3, 3, 1, 3, 3, 3, and 1. Is that clear?
Yes, sir.
What mistake you have committed? I've committed earlier in the first place, and I showed you that that is the mistake that we should avoid.
Yeah. So I still got 3. I'll check where I went wrong then.
Yeah, you need to see basically what you have taken hydrogen here as 2. Got it? You see the
Yeah.
box here, which I'm highlighting?
Yeah.
You have taken that as
2.
earlier because it is H2O. You should not take it as 2 because you have split this as hydrogen plus hydroxyl group. Is that okay?
Yes, sir. I understood.
Good. How about you, Angel?
Yes, sir.
Is this example clear?
Yes, sir.
What about Pritika?
Yes, sir. It's clear.
Right? See, the mistake earlier was you put a 2 here, then everything gets messed up. You should not put a 2 here because all water here, which you have H2O, you have split that into H and OH because you are solving the entire equation by taking polyatomic ions into account. And to have this polyatomic ion here, the hydroxyl group has to be present. So that's why we break water into H and OH minus ions. Hope it's clear, guys. I'll give you umpteen number. I'll give you how many examples do you want, guys, for the homework? Tell me, like, you'll have to solve these and show me in the next class. How many do you want, Nandana? 5?
Yes, sir.
Yes, sir.
5 will be enough?
Yeah.
Yes, sir.
Will be easy to go. What do you think? We can solve it in 20 minutes, and 20 minutes for the week is very good for us. What do you think?
Yeah, so you can give up.
Yeah, good. What about you, Pritika?
Yes, sir. It's fine.
Good. So what do we do is like I'll send you only 5 in your offline activities by tomorrow afternoon, and please make sure that by next Tuesday you will be ready with all the 5. Is that clear?
Yes, sir.
Yes, sir.
Yes.
Balancing the equations.
Okay, sir.
Great.
Okay.
Thank you. Thanks a lot.
Thank you, sir.
Sir.
See you in the next class.